Good morning, Regents. The first item today is an informational item, and it is about astronomy in Hawaii and its global impact. I'm very pleased to introduce Dr. Doug Simons, who you all know from his past life and his current role here at the university as the director of the Institute for Astronomy. So I asked Doug to give an overview from his experience, not only as a director of astronomy, but also as a director of a telescope, a Canada France Hawaii telescope for many, many years, his experiences of astronomy at Mauna Kea, and try to put all this together to show the impact, the scientific impact that astronomy has globally. So with that, I'm going to turn it to Doug to give a presentation on the global impacts of astronomy in Hawaii.
So describing the global impact of astronomy, Hawaii astronomy, in 10 minutes or so is a fairly daunting challenge, but I'll do my best. When offered the opportunity, I interpreted global impact to be beyond science. I'll start out with that, but I want to emphasize how Hawaii astronomy is relevant in a variety of ways across the entire Earth, and arguably the impact extends way beyond the confines of the surface of our planet. So I'll start with a simple graphic of a document signed back in 1968. That's the cover page for the now famous master lease that enabled observatories to function on the summit of Mauna Kea. That's a picture of Governor Burns and an entourage headed up with the then newly crafted road, Mauna Kea Access Road, to visit what was then called the Mauna Kea Observatory, single. That was really just a site testing equipment that was used to discover essentially Mauna Kea as a unique astronomy site worldwide. And what happened after that was simply impossible to predict occurring. Its accomplishments range from Nobel Prizes for dark energy and black hole research, incredible technologies that were developed here in Hawaii that I'll mention in just a bit. We have a track record of finding the most distant objects and incredible research in exoplanets. I also want to emphasize outreach and educational opportunities that are unique here in Hawaii globally. In that time, the IFA and Imiloa came into being, and some of the most remarkable discoveries like Oumuamua and Povehi that I'll touch on as well came into being. So a lot happened since that document was signed back in 1968. A few core principles that I wanted to share with you is how in terms of how I look at Hawaii astronomy in sort of a global sense. First of all, we have a 50-year legacy here today, and in many, many different respects, Hawaii astronomy is world leading. The transition to a new land authorization or master lease, as you can well aware, it's got lots of challenges, as this group knows, but I also look at it as an incredible range of opportunities that are before us, and kind of a reset after the first 50 years and how we'll advance Hawaii astronomy over the course of this century. And then a very deeply held belief that I have is that the future of Mauna Kea astronomy principally lies in the hands of the people of Hawaii, our community, your community, my community. So this is a chart that I've shown on a number of occasions. It's the total science impact per telescope. Along the x-axis there are telescopes around the world. And what's plotted on the y-axis is science impact. And that's the product of the number of papers, scientifically peer-reviewed papers, multiplied by their citations. So it's a gauge of quantity times quality. And I like it because you can score high in either sense. And I want to point out, first of all, that there are well over 100 observatories that aren't even on this chart, off to the right. The Mauna Kea observatories year after year, this is not a fluke, and it's just that year. We are extremely well represented in this key metric of overall scientific product globally. There's another way that you can look at this, and that is to basically add up all that scientific impact across co-located observatory complexes. And on the left-hand side there, you see the Mauna Kea observatories and then BLT, which is sort of the European counterpart in Chile on Cerro Paranal in Chile. And year after year, we are number one by this metric globally. I didn't put it there, but even by this metric, the Mauna Kea observatories outperform Hubble Space Telescope annually. So this is an area of science that I think uniquely Hawaii is able to lead on a truly a global scale. Another way of looking at global impact is just the international nature of all the observatories on Mauna Kea. So here's a Google shot of the summit of Mauna Kea, and each flag represents an international funder that have all come together to sponsor the vast majority of the research, the operating costs, the construction costs, et cetera, for the observatories. You no doubt saw the UHERO report. It's about $100 million per year. Roughly half of that is invested on Hawaii Island. So for me, this is remarkable because, you know, if you look at these flags, not all these countries are necessarily thrilled with each other, but the science community truly has come together in their collaboration on the summit of Mauna Kea to pursue world-class research. They did that because they know that the research potential of Mauna Kea is truly world-leading. That in turn leads to technology leadership, world-leading as well. We have right now more laser adaptive optic systems deployed on Mauna Kea than any other site in the world, including Chile. It's a video on the left that you see of laser arrow systems being used at Keck. On the right, you see 4 laser beams, sodium laser beams, actually pointed directly at the black hole in the center of our galaxy. Those are concurrent observations by Keck 1, 2, Subaru, and Gemini. Other types of technology development include the use of the submillimeter array and James Clerk Maxwell telescope. It's important legs in the Event Horizon telescope that captured the first image of a black hole named Povehi. Hawaii 4RG technology that was actually developed in large part in this office. I'm in Don Hall's old office. He passed away a few years ago. He's a great guy. I really enjoyed working with Don. And in fact, in the lab across from me right now, I noted yesterday that the James Webb Space Telescope turned on their cameras for the first time. That's the $10 billion satellite that's now about 1 million miles away. And I got a real charge out of that because that's an H4RG detector. That technology was developed right here in Hawaii. You're going to see a lot of amazing photos and images from JWST. In the picture on the lower right, that's the first instrument to use this technology. It's a high resolution spectrograph called SPIRO at CFHT. So as I mentioned before, I'm very passionate about community engagement and relations, in large part because I've spent most of my life here in Hawaii. Met my wife here. We've raised our 3 kids. And I'm convinced that in so many ways, the future of Hawaii astronomy really does lie in the hands of our local community. And that coupling is something I seek to deepen and broaden as the IFA director. One way that we do that is through a educational opportunity that is truly unique worldwide. I'm unaware of any other high school students that have access to essentially $1 billion sandbox called the Mauna Kea Observatories to pursue their own research projects. This program is now, I think, in its 7th or 8th year. We have a dozen or so high schools on 6 islands, so it truly is statewide. This is a little video from our first visit to Molokai High School. So there's Skylar, who is one of our initial winners of observing time. We were just there back at Molokai a few weeks ago, and in 2 weeks, Mary Beth Leachuk and I will be at Waipahu High School, where we will be awarding observing time there to those students. In fact, they're about to have first light for their professional grade observatory on the Waipahu High School campus. So we'll be hearing more about that as well. It's kind of a spin-off the Mauna Kea Scholar Program that we launched, like I said, about 6 or 7 years or so ago. So well over 500 students have participated in this, and no students in the world have this type of a educational opportunity except for here in Hawaii. Another program, again, world leading and unique in terms of indigenous science and contemporary science collaborating together, is through the Huahea NOAA program that is now hosted by the Emilo Astronomy Center. And Kayu Kimura and her team are doing a wonderful job of driving that since its inception back in 2017. The words, the names Oumuamua and Povehi, you're familiar with, and there are actually now 6 different major discoveries that have received Hawaiian names through this program, with a variety of participants, including Hawaiian teachers, students, and of course, Dr. Larry Kimura, who's the sort of the bedrock to the program in so many different ways. Larry and I have also, along with Kayu, given this presentation, The Physics of Po, Lessons from Nature, over a dozen times. Well over 1,000 people have participated in that exploration of the Kumulipo and how the remarkable parallels of the science that is embedded in the Kumulipo can be explored through contemporary science, and everybody learns something interesting in that process. Another area where we have a global reach is in communications and in discovery. It's kind of an interesting chart that I wanted to share with you. And it shows how effective and powerful that voice is, that Hawaiian voice through Hokuena Program. This is a chart of, I believe it's media impressions is the y-axis. And this is back in 2019 with the announcement of the image of the black hole Povehi. And to kind of scale that, that's the TMT protest in July of 2019 as well. And I wanted to point this out in that the discoveries made from Haleakala, namely Oumuamua and Mauna Kea, Povehi, and others, they really do have a lot of amplitude, shall we say, in terms of making global impact. I'm convinced that there's a real thirst for this type of discovery, and it's highly amplified by the synergy, if you will, with the Hokuena Program, providing these Hawaiian names. As I often describe the program, for me, it's kind of a way of Mauna Kea for having a global voice, and that voice is Hawaiian, very much as it should be. So putting it all together with a combination of space-based and ground-based, particularly Hawaii-based facilities, this is a nice way of showing how it's all interconnected with these billion-dollar satellites that are orbiting right now, namely TESS. And there are 3 brand new, very high-performance spectrographs on Mauna Kea now, except 2, one more coming later this year, KPF at Keck. And those will be used basically to look around the nearest stars for exoplanets. And those exoplanets, the highest or most interesting ones, will be fed as targets to JWST. You see a little animation of that being deployed. Super stoked to see the deployment completed. Now they're actually calibrating the surface of the mirror. JWST has the unique property of being able to measure the chemical composition of planets, exoplanets, as they pass in front of nearby stars. And we do that to look for what we call biomarkers in their atmosphere. So a very strong indicator is oxygen, which is highly correlated, we believe, with the existence of life. This experiment is about 12 to 18 months away. This is just amazing stuff when you look at all the parts in motion on this plot to be able to probe planets nearby. This is going to happen. Now we got Webb out there. And we're going to start looking for these biomarkers in nearby exoplanets for the first time ever, which is just an incredible stretch of technology and innovation to make that possible. Another example of how far we've come with Hawaii astronomy. I'll remind you of a hero of mine, Galileo. And he, about 400 years ago, created the first image of a solar system. It was our own. You see his sketch there, made 400 years ago with a very primitive telescope, a replica, actually. I had the thrill of being able to look through that telescope many years ago. You see Saturn and the phases of Venus there. And it took 400 years to go from the first image, if you will, of a solar system to the next image. That image on the right, the central host star, is blotted out. You see those 3 little dots. Those are planets. And that was recorded for the first time from the summit of Mauna Kea. Not only do we make images of solar systems, we make movies of solar systems for Mauna Kea. These little white dots, you see 4 of them, they're rotating counterclockwise, was recorded earlier in the past decade or so. And that's an ongoing experiment to measure the properties of those planets. So for me, when I think about this, I liken it to some of the early discovery of the Polynesians. It's a very natural extension. They were, of course, masters at exploring the ocean in search of islands. And sort of the analogy for me is our medium has changed from ocean to space itself, and our islands have now turned into planets. And that the future that the exploration that the Polynesians did, it's an extrapolation in many ways to the future that the research that's being performed on exoplanets in Mauna Kea has on our future as well. What I mean by that is I'm convinced, even if it's not our generation, it will be a future generation, not that far out, that will actually send for the first time drones, robots, just like we have an armada of them in the solar system right now. In fact, I was really amazed last week to see, for the first time to my knowledge, a proposal to NASA to launch the first interstellar probe. It's intended to have at least a 50-year lifetime and remain in radio contact with Earth through that. So it's coming at some point. And the work we're doing now from Hawaii Astronomy is to find those planets where those first drones, those first robots will be sent. at some point in the not too distant future, I believe. So with that, I wanted to share with you a 2-minute video. A lot of you will recognize the person narrating. It's another hero of mine who helped actually get me interested in astronomy when I was a kid. That I think really beautifully captures a lot of the themes that I've tried to convey in this PowerPoint so far.
We were hunters and foragers. The frontier was everywhere. We were bounded only by the earth and the ocean and the sky. The open road still softly calls. Our little terraqueous globe is the madhouse of those 100,000 millions of worlds. We who cannot even put our own planetary home in order, riven with rivalries and hatreds, are we to venture out into space? By the time we're ready to settle even the nearest other planetary systems, we will have changed. The simple passage of so many generations will have changed us. Necessity will have changed us. We're an adaptable species. It will not be we who reach Alpha Centauri and the other nearby stars. It will be a species very like us, but with more of our strengths and fewer of our weaknesses. More confident, far-seeing, capable, and prudent. For all our failings, despite our limitations and fallibilities, we humans are capable of greatness. What new wonders undreamt of in our time will we have wrought in another generation and another? How far will our nomadic species have wandered by the end of the next century and the next millennium? Our remote descendants, safely arrayed on many worlds through the solar system and beyond, will be unified by their common heritage, by their regard for their home planet, and by the knowledge that whatever other life may be, the only humans in all the universe come from Earth. They will gaze up and strain to find the blue dot in their skies. They will marvel at how vulnerable the repository of all our potential once was, how perilous our infancy, how humble our beginnings, how many rivers we had to cross before we found our way.
So I like that video. It's the title is "The Frontier is Everywhere," and it was narrated back in the 90s before Carl passed away. And I like it because it captures a lot of really impressive imagery and concepts, and it's very prescient in how he lays out a history and a future that I think we're actually living out today through the work that we do here in Hawaii and globally in astronomy. Astronomy for me, I got hooked on it as a little kid. And my first memories looking through a toy telescope I got for Christmas was of Saturn as a 7th grader, and I was hooked. There's kind of no going back. It is a science that is the pinnacle of exploration and discovery. And I think at the University of Hawaii should be something that we're incredibly proud of in our leadership role. Hawaii Astronomy is my life's work, and being able to have the privilege and honor of being IFA director and director of several telescopes on Mauna Kea is a unique opportunity that I will always be thankful for. So with a few closing thoughts to summarize things, and these are thoughts that are a compilation, if you will, of my understanding of mathematics, physics, a lot of cosmology and astronomy, and trying to throw a little Doug speak and philosophy into it as well. First of all, defying all odds, in my opinion, we likely exist in an infinitely large realm, making us infinitely small. That's the context that we have today as a result of research conducted worldwide in astronomy and high energy physics. I believe over the course of this century, the term universe will be pretty much obsolete because it's too confining. Through our determination and intellect, we're beginning to map our place in our vast home, helping satisfy our insatiable need, a desire for context and meaning. That is absolutely what's occurring every night with new knowledge coming from Haleakala and from Mauna Kea. We're on the cusp of learning if we, as life forms, are common or as rare as existence itself. Mark my words, 12 to 24 months, something like that, JWST is going to start looking for biomarkers in the atmospheres of nearby exoplanets. Super exciting. And finally, I like to remind people that we ride a wave of life that crests in our time. The wave we are riding now is unlike any our ancestors encountered. And my humble suggestion to everybody when they think about it is simply enjoy the ride. And I hope you've been able to enjoy the presentation. Mahalo for your kind attention and patience through it. I try to make it a little entertaining, informative at the same time, and also hopefully inspire those who are listening to appreciate the uniqueness, the majesty of Mauna Kea, the fact that we're able to in our own very special way, influence, I think, very positively, not only here, but the people in Hawaii, but people across the surface of the earth and future generations through the research that we're conducting each and every night here in Hawaii. Mahalo.
Director Simon, I know I am not exaggerating when I say that to regard it as entertaining and informative is a gross understatement. That was an exceptionally inspirational presentation all the way across it. And please don't be embarrassed by my words. You know I'm right.
Wow.
Let me come back to the committee and ask if the regents have any questions, please. I see no hands and hear no voices. Very well, thank you once again.
Mahalo, everybody. Take care. Aloha.